find out. So like I said, with this one, those of you at home, maybe I don't know if you can tell, some of these are pluses and some of these are minuses. Make sure you get that written down right. Zooming back out now. Okay. I'm going to win an Oscar for that, what I just did right there. Just so you guys know. Okay, so when you look at this, a couple of things. Big picture. Big picture. I'm supposed to show that this is equivalent to 0. Okay? So, obviously we have fractions. When are fractions equal to 0? Fractions are equal to 0 if the numerator is 0. So in the end, keep that in the back of your head. Whatever happens down here doesn't matter as much as what happens up here. If I can show that the top is 0, the fraction will be 0. The fraction, that whole expression will be 0. Okay? So keep that in the back of your head. This is horrible looking. It's the first one that we've done where we have two different variables or two different inputs to these trig functions. Okay? But I think the best option right off the bat is to multiply this here and to multiply this here. Okay? Now, you'll notice I'm not going to write all that out because let's again take a look at this. By multiplying this over here, like we said, that bottom is going to look horrible, right? And there's not a whole lot that can happen when I multiply this times this. But when I multiply this binomial times the top, what do you notice about them? We have a special name for these. They're called conjugates, right? The same thing in the front, the same thing in the back. And when we multiply conjugates, we get the difference of squares. So we can save ourselves a little bit of time and effort by writing this product here as the difference of squares. The bottom is not the difference of squares because these are sines and cosines mixing and matching. It's a glorious mess. Okay, so I'm not even going to write that. And here's this is kind of the point. I guess I am kind of being lazy. Okay, let's call it what it is. But I really don't care what happens on the bottom at this point. Because what matters is the top. And the same thing is going to happen when I multiply this binomial times the bottom and the top. When I multiply this times this, those are also conjugates. So the numerator over here is going to be the difference of these squares. And then I'm just going to do this. And I'm gambling, right? I'm just going to say whatever. The denominators at this point, because nothing can happen there, I can't multiply these. It would just be a string of 4 terms that would take up the entire page, right? And I'm not saying you don't have to do that. I'm just saying I'm not going to do that, right? Now when I actually add these together, my denominator is what it is. And the numerator, when I look up top, I have cosine squared x minus cosine squared y plus sine squared x minus sine squared y. And this has to equal 0. And even though this isn't one sum, I can be commutative with these terms, right? So what I'm going to do is I'm going to move this term next to this term. And I don't even have to quote-unquote move it, as long as you recognize that I have cosine squared plus sine squared. And then I'm going to move this negative term. Basically going to flip-flop these two. Okay? So we end up with this statement. Cosine squared x plus sine squared x minus cosine squared y minus sine squared y, all over this mess. And this is equal to 1. When they're both positive, that's equal to 1. If they're both negative, we can, so here's what I'm going to do. I'm going to substitute a 1 in for that statement. And from here, I want them both to be positive. I'm going to factor out a negative 1 from this term, or from this series of terms. And this is also equal to 1. So factoring out a negative, right? And I made this point before. You know, this is equal to 1. But I can't say, oh, well, if I make this a negative, then this is a negative. That's not true, right? This has to be positive. Both terms need to be positive in order for this to equal 1. If I want it to equal negative 1, I'd have to multiply everything by a negative. So this statement is equal to negative 1, right? Which is what we just saw. So from here, I always miss that, man. From here, we replace a 1 here, so we have this statement, which is equal to 0. Check mark. Okay? So, big picture. It doesn't matter that the denominator looks horrible, saving ourselves the hand cramp of having to write that, because I just needed to prove that the numerator would equal 0. Okay? More increasing the tolerance for multi-termed expressions.